Hi, in this chapter we are going to talk about breadth first search, so let's get started. What is a breadth first search? It is a very important graph traversal algorithm. We visit every vertex exactly once, and we visit each neighbor vertex, then the neighbors of these new vertices. So we go layer by layer. The running time of the algorithm is proportional to the v plus e, where v denotes the number of vertices, the e denotes the number of edges, so it's ordo v plus e. But it has to store a lot of pointers, so it is not as efficient as depth first search. We are going to see that for depth first search there are no pointers, so depth first search is much more memory friendly. It constructs shortest path trees, so this is the main advantage of breadth first search. That, for example, Dijkstra's shortest path algorithm does a breadth first search if all the edge weights are equal to 1. So what's the disadvantage of breadth first search? That it has to store a lot of pointers, and that's why it's not so memory friendly. And what's the advantage, on the other hand? That it constructs shortest path, and sometimes it has several important applications. We are going to talk about it later at the end of this video. So let me illustrate how it works in practice. We have a tree-like structure like this. To be exactly precise, it is a binary search tree, and we want to traverse it in a breadth first manner, and we start at the root node. We visit its neighbors and visit both of them. Then we visit the neighbors of its neighbors, because the tree doesn't have any left or right child. We keep going with the node 2 and visit its children. Then the 4 has a single left child, so we visit it. And that's how breadth first search works. It goes layer by layer, and it is something different for depth first search. We are going to see that the depth first search tries to go as deep as possible, so it's not going by layer, so from layer to layer. But breadth first search works like this. So breadth first search in artificial intelligence and machine learning, it can prove to be very important, because the robots can discover the surrounding more easily with breadth first search than depth first search. So, okay, we have to store lots of pointers, but who cares? It still is important. And it is also very important in maximum flow algorithm. The Edmonds-Karp maximum flow algorithm uses breadth first search for finding augmenting paths. There's a distinct chapter concerning maximum flow problem. We are going to talk about it later. And of course, the Cayenne's algorithm in garbage collection, as far as Java programming language is concerned, it is similar to mark and sweep procedure. It helps to maintain the active references, and it uses breadth first search to detect all the references on the heap memory. And if there are no references that are given nodes, for example, then this algorithm is going to free that memory. So these are the applications on breadth first search. Thanks for watching.